No. No. She was on the ministry side. Number 7. Well, since we're solving by graphing, we need to get it equal to 0. Well, we have 2 things on one side already, so we can just move the 8x over by subtracting, which would give us 0. It's equal to negative 4x squared minus 8x minus 4. So we moved the 8x over by subtracting it from both sides, and then I reordered it into standard form. Standard form's x squared x constant term. So then we do y equals negative 4x squared minus 8x minus 4. So it intersects the x-axis at exactly 1 point. Second table. And that point is negative 1. X equals negative 1. There's actually 2 spots. It would be negative 1 and negative 1, but we can just say negative 1. What's the equation for number 8?
It's 3x squared equals 6x minus 3.
Get it equal to 0.
I didn't know if 6 would be plus or negative. Plus or minus?
Is 6x positive?
Okay, yeah. That's what I thought. That's what
Yep.
I thought. But it would be opposite.
Negative 3x squared plus 6x
Oh wait, you could put negative 3x in there?
minus 3. Well, the number that goes first is going to have to be negative. The calculator really will not like it if you do minus 3x squared. Because if I do minus 3x squared, it says it's fine. But when I say graph, it's going to say syntax error. Now, if you tell it to go to, it's going to say that minus needs to be changed to a negative. Because if you put a minus there, it's looking for something in front of it to subtract it from. But since there's nothing in front of the x squared, that negative, or in front of the 3, then it has an error. Well, here, x is 1. Actually, x is 1 both times. Questions on this here? So you want to find out what value of x makes the y value be 0. It is possible that x could also be 0, but we would need 0 and 0. Yeah. Because what values of x give us y equals 0, so when we write those x values down. Complex conjugate theorem. If f is a polynomial function and a plus bi is imaginary 0, then a minus bi is also 1. Well, a plus bi's complex conjugate is a minus bi. So if 7 minus I is 1, its complex conjugate would be 7 plus 7 minus i's complex conjugate is 7 plus I. That's finding the complex conjugate. Now, one thing I want to do is actually multiply these together. Because when we multiply them together, something interesting does happen. Let's focus up here. So the first thing we're going to do is 7 times 7, which is 7 times I is plus 7I. Negative I times 7 is negative 7I. And lastly, negative I times I is negative I squared. Now, 49 does not have any like terms at the moment. What's our 7i minus 7i? 0. And we said yesterday I squared is -1. Well, 40 minus -1 is?
50.
And that's interesting because if we multiply the complex conjugates together, because we had two terms with I, we multiply them together, we get a single term that has no I in it. And that's what's interesting with complex conjugates. Now the homework is going to ask for the first part to find the complex conjugate and their product. So for this one here, we would need 7 plus I and 50. Yeah. We can see it with the next one. What's the complex conjugate? Yes, -5 plus 5i.
So it's not changing anything.
Well, we did, technically. Right, because what sign are we changing? We're changing the sign in front of the I. We're changing the sign in front of the I. And to find their product, we're going to do -5 minus 5i times -5 plus 5i. And we could type this into the calculator. -5 plus 5i times, bless you, -5 minus 5i. Enter, and we get 50. Bless you. They won't always equal 50. It just works out that these two did. Questions on this here?
Which one is C?
Both. Yeah, because for the homework, we're going to want the complex conjugate and their product for the first part. Questions on any of this here? We ready for the next one? 2 plus 4i. Complex conjugate would be? -2 minus 4i. Now we do need to multiply the two together to get their product, which would be? Well, -2 squared is 4, and 4 squared 16. Then we would add those together. But I would do, in the calculator, we could do it as -2 plus 4i times -2 minus 4i. If we type that in, we should get 20. Y'all get 20?
Yeah. First I got some things here.
You might have put a minus in front of one of the 2's instead of a negative.
I think I put it here. I don't see that one.
I could do it too. Number 4, what's the complex conjugate? 3 plus 6i. And if we multiply those together, we get 45. Questions on complex conjugates and their products? We feel good with these here?
Yeah.
10 minus 2i would be 10 plus 2i. And our product is 104. Let's -4 minus 8i, -4 plus 8i, Do you agree? And I think we feel good with these here, yes? Write each quotient in standard form. Now, standard form does not have I in the denominator. We need to get I out of the denominator. Alpha y equals enter. So let's try to type it in the calculator first. 4 plus 3i over 1 minus 2i. 4 plus 3i over 1 minus 2i. Yes, when you get the typed in, go on and hit enter. Alpha y equals enter. How are we doing? Pretty good so far. Yeah. Yeah, this is, if you notice, there's a difference in our calculator types. The one on the board is a TI 84 plus CE. Yours are just 84 plus. Yes, for some reason, when they updated it to the CE, they added the ability to do this. It is, those still can do it. We do have to do it a little differently. I'll show you that here in a minute. Yeah, the CE edition of this calculator can do it as a fraction. We have to do it a little bit differently. Alpha y equals enter. So now I'm going to show you how to do one of these by hand, then I will show you how to do these in the calculator. Now, what we have to do to get to the answer is we need to get I out of the denominator. Well, 1 minus 2i is in the denominator. If I multiply it by its conjugate, 1 plus 2i, as we've seen already, the I terms will simplify out. But I can't just multiply the denominator by 1 plus 2i. I also have to multiply the numerator by it. Now, the reason we can do this and not change what the fraction is because what is 1 plus 2i divided by 1 plus 2i? 1. Anything divided by itself is 1. So really, what are we multiplying this fraction by? 1. It's just a fancy version of 1. So it's going to change how it looks, it's just not going to change its value. Now, if we distribute the denominator, 1 times 1 would be 1. 1 times positive 2i would be plus 2i. Negative 2i times 1 be negative 2i. And lastly, negative 2i times 2i is negative 4i squared. Not a whole lot. Because really, if we simplify the denominator, we have 1. What's 2i minus 2i? What is I squared? Negative 1. So that's all we have in the denominator. The numerator, 4 times 1 is 4. 4 times 2i is plus 8i. 3i times 1 is plus 3i. 3i times 2i is plus 6i squared. Now in the numerator we still have the 4. 8i plus 3i is 11i. Well, what is I squared? Negative 1. Well, our 6 times negative 1 is, I moved it over to the 4 because they are like terms. Our negative 4 times negative 1 is just 4 plus 4. In the top, 4 minus 6 is plus 11i over 5. Now, the other way we can write the answer is by splitting the fractions up. But I would take either version of the answer. Yes, there's a good number of steps, but on a whole, there's not that much to it. Questions on this here? We ready for the next one? Well, as we've seen already, the graphing calculators that y'all have do not want to do these here. So instead, let's type it in like this here. Instead of using a fraction, well, a fraction is just division. 1 minus 4i over 2 plus 3i. So 1 minus 4i divided by 2 plus 3i. You will need to make sure to use the parentheses, otherwise it will not give you the correct answer. Because it will only divide the middle two, so in this case it would have been negative 4 and 2, and then just did addition and subtraction. Math, enter. Because we want it as fractions, not as decimals. Because if we hit math, the first one is fraction. Enter gives us this here. Math, enter. Because the first option in because the FRAC is telling it take the previous answer and turn it into a fraction. So negative 10/13 is it minus 11/13? Yep. And that's it. Questions on this here? We ready for the next one? Two plus 5i divided by 4. 2 plus 5i divided by 4i. Now this one here might not need the parentheses around the 4i, but it's better to include them and not need them than need them and not have them. Almost. Because we've got to go math, enter.
Instead of actually putting in a fraction, we divide.
Yes. Divided by 4 second. Math, enter. And it brought up a different menu. 5/4 minus 1/2i. Questions on this here? Do we need to see another one of these? Yes? Okay.